So today I'll be showing um, how to run the the Project1 for answers. So here, started with the geometry, and we would go to the geometry in designer mode. So it would open from workbench. It would open to designer mode. So here we have our sketch one with everything we need. Um, named our borders, shaded our area, circles with one diameter. So from there, we would go to our mesh. So from our mesh, takes a lot to open up, but from our mesh, we will open up our mesh that was already made. Here you could see all the triangles. Um, the diameter is still 1 meter, and then all the nodes. Here I can show you this. Alright, so here we can show nodes, how many nodes I have, about 180,000, and then 297,000 elements. And then from here, we did some edge sizing for our middle, to make our middle more prominent. We did some inflation. And then from here, we went over, we have to update it, didn't make any changes to it. We go to our setup, here. So I'm going to be showing you how I did um, case 3. So this is going to be for our turbulent. We have it set there. We want the energy equation on. Then make sure our viscosity that we calculated. And then our density is 1. And then our boundary conditions, since case 3 is stationary and not rotational, you don't have to do much, but just make sure it's stationary, apply, close. And we would initialize hybrid, more settings, 35, number of iterations, 35. And then to run our calculations, 1,000 iterations, it will diverge at some point. So we'll initialize and calculate. Show you what's going on here with our residuals once it starts converging. So it's going to start calculating here soon. Just kind of slow here, but essentially, so this is a mesh. This is a mesh right here, our starting, and then it's initiating right now. I run it to 35, and then we can make sure that it will definitely start the iteration 1 to 1,000. I won't let it go to 1,000, but this is how the iterations start. Apologize for it being a little slow. My computer isn't fast, but So yeah. From there, we'll let the iterations run a little bit, and then what we'll do is show you where we can get the contours, we get the XY plots, and then our forces, which will help us find our lift and drag. So I'm only gonna let it get to about 80 iterations just to show you that everything's running properly, and that we'll make sure to have everything we need. This is our energy equation line. This right here, I'm sorry, the blue line. So let it get to about 80 or 90, maybe 100 iterations. It's actually going to show us once it's done. Once I stop it, here, I'll stop it right now. Stop. It's going to show us contours, velocity, magnitude, static. These are our previous ones, so these aren't necessarily what we are going to use, but I'll show you what we'll use to find. So here we'll go to contours, and then contour lines, erase that. We'll do our velocity, compute, everything, compute, and then this is what we'll get. Since I didn't let it do many iterations, this is what we're getting so far. Then I'll show you our pressure, our static pressure, compute. This is a little bit better. This is showing a contour for static pressure. Then I'll show you our XY plot. So we'll do the pressure coefficient, just a cylinder wall. This is what we get. This is how we would get it. Then we would do our velocity plot here as well, velocity magnitudes, and then it's just going to be a straight line. So we have to change this. So yeah, for velocity, we have to make y1, making it the same. And then to find our forces, we going to find the lift and the drag. This is how we would do it. And then this is here. And for our drag, we make y1, print it in, and then this is where we get our drag. Close, and then obviously the streamlines we could do by going to results, and then yes, for a new one. This will show how we got our streamline. So it's going to refresh here. I'll change a couple things. Sorry, it takes a minute. It's loading here. It shouldn't take that much longer. And then it's going to be a velocity streamline. So again, it's taking so long. Should be done in a second. And this is how we get our streamline. Sorry, once it gets there. So yeah, so this is our streamline. Uh, Something is off with my numbers, but this is how you would get it. It doesn't necessarily, for case 3, this isn't how you would get it. Um, this isn't what it looked like for case 3. It should look something like this. Uh, this would be our streamline for case 3. And that is it. That is how you get everything. And you obviously just change for case 2, change for case 1, and just make sure you have everything according, all the units, everything you need, the density and the viscosity, and you should be good.